Alright class, so for today in geometry we're going to be doing segment addition. So let's say you have a line, starts at A, goes all the way to C, it's two endpoints, and let's say there's some point B in the middle, like that. And if I tell you that this part right here is 5, and that this part here is 12, so from A to B is 5 and B to C is 12, what is the length? What is the length of AC? I think most of you can understand that that's 17. I think you can understand that because, well, I know 5 plus 12 equals 17. And you're correct. That's kind of what we want to do today. We want to show that when you add two segments, like the internal parts of the segment together, you'll get the whole segment. So, let's look at another example. One that has to do with a little bit more algebra. So let's say there's another segment. Let's call this one D, and it goes to F, with some point E in the middle. Let's say I'm kind of a jerk, and I tell you that DF equals, let's say, 20. And I tell you that DE, that part is x plus 1, and this part right here, EF, is 3x let's make it 3x. No, wait a minute. Let's make it plus 3. So now I want you to find what DE and what EF is, sorry. A little bit trickier now that we're not just giving integers, but the same concept still applies. We know x plus 1, and we know 3x plus 3 equals those two, and we know the whole thing is DF, which is 20. That means, just like before, if we add the two segments in the middle together, we'll get the whole thing. So that means I know that 20 has to equal x plus 1 plus 3x plus 3. So, if we're still trying to find the length of DH and EF, we're going to have to solve for x. So, combine like terms, we have two x values here, we have two number values here, so x plus 3x I know is going to be 4x. And I know 1 plus 3, that's obviously going to be 4. That equals 20. So I'm going to subtract 4 from both sides. And I'll get 16 equals 4x. So now, if I just divide both sides by 4, I know my answer is going to be x equals 4. Boom, hard part's over. But if you look at the question, it's not asking for what x equals, it's asking for the length of DH, or DE and EF. So what we need to do is we need to plug those in for our x's to those two segments. So I plug in 4 for DE, so that's going to be 4 plus 1. So I know the length of DE is going to be 5. And I know the length of EF, I plug 4, and that's going to be 3 times 4, which is 12, and then 12 plus 3 will be 15. So that's going to be EF, it's going to equal 15. The nice thing about problems like this is you can always check your work at the end. So if we know DE equals 5 and EF equals 15, we can add those together and see what we get and see if that's the same thing we started with. So 5 plus 15 is 20, and at the beginning we said DF equals 20. So obviously we did it right, because our math works out at the end. Now, let's do another problem like that. A second, see if I can do a layer quick. Alright, so this is kind of the second part of the lesson. Say we have another line. Let's go from X to Z. And it has some point Y right in the middle. And I tell you Y is the midpoint of that segment. Sorry, it's kind of hard to write for some reason. It kind of dictates what you're trying to say. So Y is the midpoint. Let's say I tell you that this right here is 14, and then from X to Y, and then from Y to Z, I tell you that it's 3X plus 5. So you think, what is the difference between this problem and the last problem? This problem, I told you what the whole segment length was, so we had to add the lengths together to figure out what X equals. This one's a little different, because I tell you what both internal segment lengths are, but not the whole thing. But I tell you something that's very important, and that Y is the midpoint of that segment. That means these two lines have to be congruent. They have to be equal to each other. That means we know we can set them equal to each other. So 14 equals 3x plus 5. And that's our equation. So now we can solve for x here, and then we can plug it back in to figure out what y to z is. So just like a normal problem, I would subtract 5 from both sides. I know it's going to be 9 equals 3x. And then divide by 3, and I know my x is going to be 3. So, now, just like we did before, plug it in for the x. So that's going to be 3 times 3 plus 5. And I know that's going to be 9 plus 5, which is 14. So I know xy is 14. I know yz is 14. And if I wanted to find the whole segment length now, if I know that's 14, I know yz is 14, I know xz would have to be 28. And if there's any way we could check our work, obviously xy and yz have to be the same thing, and we just found yz to be 14, which kind of proves that we are right.